Hello everyone, I am Mohammed Sadique. I am representing the Coral Bench. This video focus on Module 1 and Course Capstone Project where taken 20 coding problems. So I will be addressing and explaining 5 of these 20 coding problems. So I am going to explain my first problem, which is code bug fixing problem. It is belong to the code bug fixing. So this program is used to check if a number is a power of 2 function that takes a parameters n return n greater than 0 or n and n minus 1 equals to 0. This line checks if n is greater than 0 or if the bitwise and of n and minus 1 is 0, close the is power of 2 functions. The issue in this program, the logical or operator should be a logical and operator because a number can't be both greater than 0 and have the bitwise and equal to 0 for it to be a power of 2. The correct program here written and greater than 0 and logical operator and n minus 1 equals to 0. This line checks if n is greater than 0 and if the bitwise and of n and n minus 1 is 0, close the power of 2 function. The usage example console.log calls the power of 2 functions with the argument 16 and logs the result 2 in this case. And other example was the power of 2 function with the argument 5 and logs the result false in this case. The initial solution bad an error in the logical operator instead of and logical operator, which was corrected in the second solution. The corrected code correctly determines if a given number is a power of 2. The second problem, this program is used to count the minimum number of parentheses to add to a string to make it valid. This function min add to make valid that takes a string s as an input variable. As an input variable initialize let open is equals to 0, close is equals to 0. Initialize two variables open and close to keep track of the count of open and close parentheses respectively. Use our input string for let characters of string. Iterates over each characters in the input string. Counting parentheses. This statement, if the current character is an opening parenthesis, increments the open count. As if this statement, if the current character is not a opening parenthesis and there are open parentheses open greater than 0, incorrectly increment the close count. Else open, if the current character is not a opening parenthesis and there are no open parentheses, open equals to 0, decrement the open count, returning the result. The corrected code here, variable initialize let open equals to 0, close equals to 0, initialize two variables open and close to keep track of the count of open and close parentheses respectively. Use our input strings. For let character of string, iterate over each characters in the input string. Counting parenthesis, if characters equals to open and close parenthesis, open increment. If the current character is an opening parenthesis, increment the open count. Else if equals to close parenthesis and logical operator open greater than 0, open decrement. If the current character is a closing parenthesis, then there are open parentheses open greater than 0, decrement the open count to match the close parenthesis as close plus plus increment. If the current character is not a opening parenthesis of there are no open parentheses, increments the close count to indicate an invalid closing parenthesis, returning the result. Return open plus close, return the total count of open and close parentheses, ensuring that each closing parenthesis has a matching opening parenthesis. And the third problem is function sort people. This function that takes two array names and heights and parameters. Let length equals to height. Let parenthesis increment usage of length should be length to get the length of the heights array. Let map new map initialize a new map to store heights and the corresponding names. For let I equals to 0, I smaller than equals to length I plus plus. Loop should run until I smaller than length to avoid going out of bounds. Map dot set heights I names I. Map each height to its corresponding name. Close the loop. Heights dot sort the heights array in the descending order. Let race equals to array. Initialize an empty array to store the sorted names. For let height for heights, iterate over the sorted heights. Race dot push map dot get heights. Push the name corresponding to each heights into the result array. Close the loop. Return trace returns the sorted names array. Corrected solution here var sort people equals to function sort people function let length equals to heights dot length remove after length. For let I equals to 0, I smaller than length I plus plus. I smaller than equals to length to I smaller than length to avoid going out of bounds. Console.log sort peoples names heights. Call the sort people function with the example arrays names and heights and logs the sorted names array. The initial solution bad errors in using length instead of length and in the loop condition. These were corrected in the second solution to ensure the function works as expected, sorting the name based on their corresponding heights. And my fourth problem, function find error nums. That function takes an array nums as a parameter, initialize a hash map to store the frequency of each number, and output array to store the duplicate and missing numbers, and max value to keep track of maximum number in nums, begins a loop from 0 to nums dot length, including an attempt to access an element at num dot length, which is out of bounds and will result in undefined. Retrieves the number at index I and checks if it already exists in the hash map. If so, it pushes the duplicate number to the output array. Then it sets the number's index in hash map and updates the max value. Loops from 1 to max value plus 1 to find the missing number. If a number is not found in hash map, it is pushed to the output array and the loop is excited. Return the output array containing the duplicate and missing numbers. The corrected solution here var find error nums is equal to function. This similar to the initial solution, but the loop condition have been corrected to iterate over the valid indicate of nums. Corrected the loop condition to iterate up to max value and adds a before hash map dot hash I to check if I is not present in the hash map. Return the corrected output array. The initial solution had error in the loop conditions, which goes out of bounds axis and incorrect iteration. These issues were corrected in the second solution to ensure that the function worked correctly, finding the duplicate and missing numbers in the input array. The fifth problem is palindrome. Palindrome function that takes a number and as input, initialize num to 0 to store the reverse number and back and to store the original number. Reverse the number and store it in group num using a while loop. It repeatedly takes the last digit RAM of n, adds it to group num. Group num means duplicate number and updates n by removing the last digit, compares group num with the original numbers back n, and returns true if they are equal, indicating that the number is a palindrome. The second approach that is correct, using two pointer approach, define the is palindrome function using the two pointer approach, taking a number n as input, checks if n is negative, in which case it returns false since negative numbers cannot be palindromes. Initialize original to n to store the original numbers and reverse to 0 to store the reverse numbers. Reverse the number n and store it in the reverse using a while loop. It repeatedly tracks the last digit of n, adds it to reversed, and update n by removing the last digit. Compare the original with the reverse number, reverse and return true if they are equal, indicating that the number is a palindrome. Both approach aims to check if a given number is a palindrome by reversing the number and comparing it with the original number. The second approach uses a more efficient two-pointer approach to reverse the number. Thank you.